Hello, Assalamualaikum. I Ahmad. We will present about group project CSC520. Okay, I will jump to next slide. Basically, for our team is I am me Ahmad. My team Jazmi, Zamani, and Haziq for my friend and my friends. So explanation of OS concepts. So basically, system scaling is how the OS manage CPU time between process like conductor, manager, and orchestra. Is aimed to maximize resource use and provide a good user experience by balancing CPU utilization, throughput, and fairness. Various algorithm is this each with the trade-offs from the simple FCFS first come first serve to more complex multi-level queues. So the scheduler adds process to ready queue, chooses to run next and performs context switches. Good scheduling is a key the responsive and efficient system. Thank you.
Assalamualaikum, my name is Muhammad Azamani and I will be talking about the details of program implementation. So our program is CPU scheduling simulator, which we will be simulating the round robin and priority scheduling. So this simulation will show how multiple processes are managed within a system. So the round robin scheduling will be simulated using its quantum range. Meanwhile, the priority scheduling will be simulated using its priority order. Alongside that, our program will generate a Gantt chart representing the process order. And finally, the program will calculate its waiting time and turnaround time alongside its average. So starting off, I will be explaining the code logic and flow of the round robin scheduling. First, the scheduling will be executed in a process within a fixed interval, which in this case will be called as quantum range. So the process will be preempt if the burst time of the process exceeds the quantum range, and the process will be added back into the queue. The cycle will be repeated until all of the process burst time has been executed. So how exactly the system works? The quantum range, the value will be determined early by the user, and this quantum value will decrement each of the burst time value inside the array until all of the value has exit the array, which means the process has been completed. And once complete, the program will produce a Gantt chart, and the waiting time and turnaround time will be calculated alongside its average. Okay, moving on, the code logic and flow for the priority scheduling. First, the priority scheduling will execute each process with its priority order. The lower the value, the higher the priority. This program will run until all of the process are completed according to its priority, same as before with the round robin. So how did we implement this scheduling inside the program? The process are sorted in ascending order inside an array utilizing the bubble sort algorithm, which means the lower the value, the process will be in the front, and the higher the value, the process will be at the back, which means the process in the front will be completed first, and the process with the higher value will be completed last. And once completed, this program will generate its Gantt chart, and it will calculate its waiting time and turnaround time alongside its average. And now for the demonstration, I will pass to the next team member.
Assalamualaikum, my name is Jazmi and now I will present a demonstration of our program. In our program, we provide two option scheduling, which is round robin scheduling and priority scheduling. So for this demonstration, I will focus on round robin scheduling. Now for the input number, we choose 1 to round robin scheduling. Okay, for the number of process, here we set 3, and for the example process P1 we choose 12, P2 6, and P3 5. Now we set the time quantum for round robin. Here we set 2. Okay, the program then execute the round robin algorithm and produce a Gantt chart which visually represent how processes are scheduled over time. For example, P1 to P2, P3, P1, P2, P3, P1, P1, and go to P1. And for the time increment at 0, 2, 4, 6, 8, and up to 23. After that, when the scheduling is complete, the program calculate the waiting time and turnaround time. For the process P1, P2, and P3, the waiting time is same, but for turnaround time, for P1, turnaround time is 18, and for P2 is 12, last P3 is 11. For the average waiting time is 6, and the average turnaround time is 13.67. And that's all from me. Now we go to the priority scheduling.
Assalamualaikum, my name is Ahmad Haziq bin Azni, and for today I'm going to demonstrate our system, which is CPU scheduling, and I will demonstrate the priority scheduling part. In the first part, you are going to choose the type of process, and I'm going to choose 2, which is the priority scheduling. And then you need to enter the number of process that you like. I will enter 4, and then it will redirect you to put the burst time for each of the process, and it start with process 1. Right now I'm going to put 5 for the process 1, and the priority for process 1 is 4, and then for the burst time of process 2 is 10, and the priority for process 2 is 3, and the burst time for process 5 is 15, and the priority for process 3 is 1, and the last one is the burst time for process 4 is 20, and the priority is 2. As you can see right here, after the last process 4, it will generate a Gantt chart, and it is shown right here. And then down here we got a table that will show the process, burst time, waiting time, and the turnaround time. So as you can see right here, we got process 3 with the burst time of 15, waiting time of 0, where it's enter, and then the turnaround time is 15. And then for process 4, it become the second priority because it be written here, and it got the burst time of 20 and the waiting time of 15, and then the turnaround time is the addition between the burst time and the waiting time. And then after that we got average waiting time. As you can see, it is 23.75. This is the result after the addition of waiting time of 0, 15, 35, and 45, and divided by 4, or the remaining, or the number of the process. And for the last average is average turnaround time. As you can see right here, we got 15, 35, 45, and 50. And then it is divided by 4 because it follows the number of process, and we got the result right here, 36.25. And that's all from our group. Thank you.